problem, and in this problem we have a wire that's formed into this shape of two semicircles connected here. There's current flowing around this closed loop that looks like this, and we want to find the strength and magnitude of the magnetic field at point P. So what we can do in this problem is we can think of it as having four segments. So on this segment the current flows along this way, we'll call this segment 1. Then along this segment, it's got a radius of 1 centimeter. Current flows along this way, we'll call that segment 2. Then the current comes down through this part, we'll call that one segment 3. Then last, the current comes up around this way. That's going to be segment 4. We'll just make those arrows nice and big so we see which way the current is flowing. So what we can do is find the magnetic field at point P due to each segment, add them all up, and then we'll have our net magnetic field. Let's start with segment 1. Segment 1 is a bit of wire that points this way. The current flows like this. Our point P is right here. So there's our current I. To find magnetic field, we'll use the biot law, which says that the magnetic field is the integral of mu naught, permeability of free space, divided by 4 pi, times current times ds cross r hat over r squared. We've got to ask, what do we mean by each of these? I is the current, that's 5 amps. ds is an element of path along the wire. Let's draw ds. So we just pick a little bit along the path. It's parallel to the current. So there's ds. And r is a vector which goes from ds to our point P. So there's vector r. R hat is a unit vector which represents the direction of vector r. So that's a little bit in the r direction. Let's draw that guy. There's r hat. Okay, now we know where everything is. Let's use our biot law. Let's do ds cross r hat first. So for this one, ds cross r hat, the magnitude of ds cross r hat is the magnitude of ds, the length of that little piece, times the magnitude of r hat, it's a unit vector, it has a magnitude 1, times the sine of the angle between ds and r hat. Those two guys are parallel. The angle between them is 0. And then sine of 0 is 0. So ds cross r hat is 0 because they're parallel. That means the magnetic field due to the segment 1 is equal to 0. Okay, in the next part we'll find the magnetic field due to segment 2.